So this is chapter 4.1, part 2, and what we're doing is we're continuing to work with angles that are not only measured in degrees but also measured in radians. So we're going to be doing measurements and calculations that deal with coterminal, supplementary, and complementary angles. So first of all, when you walk away from this video, you're going to want to make sure that you know what coterminal angles are and how to find them. You're also going to want to be able to calculate complementary and supplementary angles, which means keeping them apart. And you're going to want to be able to convert minutes and seconds to decimal degrees. This sign is something that you're going to start to see a lot more. And what it means is it's called theta, but what it is, it's a variable that's going to represent specifically an angle measurement. So whenever you think this, you really think to yourself angle. Normally we would use X or letters that would represent some sort of unknown. Instead, we're going to use this theta to represent an unknown angle. Alright, so here are two vocabulary words that we need to keep straight. One way that I would say to remember this is you compliment someone when they are right. So a right angle, which is 90 degrees. So you compliment them when they are right, because sometimes people are prone to be like, oh, complementary is at the 90 or the 180. Complementary is going to be the 90. Alright, so that leads us to supplementary angles. Those are angles that add up to 180 or pi. Remember, if we're going to look at a circle and we want to go halfway around, you can either look at that as 180 degrees as an angle that you opened up from that center, from that positive x-axis and opened up this way, 180 degrees, or you could look at it as not 2 pi radians all the way around, but instead just pi, because we only went halfway. 90 degrees would get us right about here, but otherwise you could also look at this as, well, we know that halfway around the circle is pi, so if you halved that, that's going to be pi over 2, right? 1/2 pi. Let's look at an example of how we work with these complementary and supplementary angles. So find, if possible, the complement and the supplement of each of these given angles. So I'm going to start with the complementary angle. I'm just going to write comp. Again, by definition, what that's saying is we want two angles that add up to be either 90 degrees or pi over 2. So I'm going to start by saying that I have pi thirds here, and I want to figure out that unknown angle that's going to add up to pi over 2. So if you looked at your circle, let's go ahead and just look at this visually. I want to kind of understand, where does pi thirds lie? So again, this is going to be right here, our pi, right? If you go halfway around the circle, you went pi. If you went all the way around, it's 2 pi. And then I'm going to break this up into 3 equal portions, because I know that I want to take my pi and divide it into 3 equal portions. This right here is literally 1/3 pi, or in other words, pi over 3. Okay, so that's where I'm at. Is this right here, I want to figure out what is this angle going to be equal to. So that's what I'm solving for right here. So in order to solve for that, I would just have to take pi thirds away from each side. Okay, so then I'm going to get, just like solving for equations, solving for unknowns. So I'm going to go write this out over here. And here's the deal, just like any fraction, what we need is a common denominator. So I'm going to multiply this by 3, which means I need to multiply the top by 3. So you can see here I've taken this term and I've multiplied it by 3 over 3, which is just 1. So therefore I haven't changed this at all by multiplying one of these terms by 1. And then I'm also going to multiply this by 2 over 2. So again, haven't changed anything at all. So this unknown is going to be equal to 3 pi over 6 minus 2 pi over 6, which is going to get me 3 pi minus 2 pi is just pi over 6. Right? It's just like if you had 1 minus 1/4. Don't forget our basic rules of fractions. I would need a common denominator, right? And then you just subtract the tops once you achieve that common denominator and put it over the common denominator. 1 minus 1/4 would be 3/4. 3 pi sixths minus 2 pi sixths would get us 1 pi sixth. Now let's think about our supplementary angle. So I'm going to that sup. So here I want to figure out not just this portion, but all the way over. Okay, I hope you can kind of see what it's going to be. It's going to amount to be 2/3 pi, because here is 1/3, here's another third, 2/3 pi. But let's go ahead and do that. So by definition, supplementary means that I want two angles, so here's the given one, plus some unknown angle to add up to be pi. So again, to solve for this, sorry, I have to go down over here. I'm going to subtract off pi/3 from both sides. And what I'm going to get is then theta is equal to pi minus pi/3. And again, I'll need a common denominator, which will be 3. So 3/3, still that's just pi. And then when I go ahead and subtract this, I get that my theta was equal to 2 pi/3, just like we could visually see here. Alright, so the second part of this is keep in mind if possible, because now they want us to find this. So I'm going to go ahead and say, let's look at a circle and mark where 3/4 would be. So again, here's my pi, and what they're saying is they want 3/4 of that pi. So here was that halfway mark. I'm going to divide those in half so that I have 4 equal sections. This right here would be 3/4, or in other words, 3/4 pi. Okay, so the deal with this is we can't really have a complementary angle. Technically, someone could argue you could take that angle, 3/4 pi, and then add on to it a negative angle, one that goes in the clockwise direction. But for this, what we're saying is no. If it's over 90 degrees, it's not going to have any complement, right? If it's obtuse, in other words. So really for this one, all we can do is the supplement. We need to figure out the supplementary angle. So it's this piece right here. And again, you can probably visually see it. It's going to be pi/4 is what we really have left to go to get to that pi. But let's go ahead and calculate that. So we do know that 3/4 needs to be added with some sort of unknown angle in order to equal pi. And when we subtract 3/4 from both sides, what we get is theta is equal to pi minus 3/4, and I need a common denominator, so now I can just subtract straight across the top pi/4, just like we predicted. Alright, so pi/4 is the supplementary angle to 3/4 because they add up to be pi. Alright, here are some more vocabulary words. Coterminal angles are those that share the same terminal side. Remember, when we're looking at standard position angles, we might have something like this, and we're going to open up an angle like that. Alright, we could also have something that went around this way, right? And that also would still have a terminal side ending in the same spot. Or I could say I can open up and then keep walking around my circle and overlap, and I'd still wind up in the same spot. So all of these different things that I just did here are finding the same exact angle. So to find coterminal angles in radians, think about to go all the way around the circle like I just did there, that would be 2 pi radians. Not only did you walk a certain amount of radians, but then you did a full cycle of 2 pi. And then otherwise, to find it in angles, you're more familiar with that, you can add or subtract 360 degrees. So open up an angle here, and then open up again 360 degrees all the way around, you're going to wind up in the same exact spot. Alright, so number 17, determine 2 coterminal angles, one negative, one positive. So if we wanted to go positive, keep in mind you could have opened up to this pi/6, but then you could have continued walking around that circle for 2 pi more radians. So it would have been pi/6, oops, sorry, keep going, plus 2 pi. So again, you need a common denominator, which is 6, so I'm going to multiply the bottom by 6, which means I multiply the top by 6. So I would get 13 pi/6. So you not only went 12 pi around, but you went one more pi sixths around. Okay. Alright, let's contemplate negative here. If you wanted negative, so that would mean that you went in this direction, and then you added on negative 2 pi, or a clockwise direction. So what would happen here for the negative is you could just take your pi sixths minus 12 pi sixths, okay, or that's in other words 2 pi, and what we're going to be getting then is 1 minus 12 is negative 11 pi sixths. Okay, so there are two coterminal angles that are negative and positive. Alright, let's look at 5 pi sixths. I'm going to do something a little crazy here, and instead of just saying I'm going to walk to that 5 pi sixths and walk around 2 pi, I'm going to add another 2 pi to that. And what you're going to see is that you would get that distance, that same amount of distance as if you had just walked 5 pi sixths. So we're going to have 5 pi sixths plus, and I added 4 pi onto this. 2 pi plus 2 pi. So again, common denominator, multiply by 6, multiply the top by 6, then I get 29 pi sixths. Okay, so there's one coterminal. And if we wanted the negative, I could have gone this direction instead. So all we have to do is figure out, well, you have this pi, 5 pi sixths. Just subtract from it 3 pi, or 2 pi, sorry. So when you do this, you're going to get negative 7 pi over 6. The last skill, so we've been able to now find coterminal angles, complementary and supplementary angles. So the last thing that we want to do is we're actually going to go back and work with degrees. Degrees can be measured in pieces, so just like longitude and latitude lines, you don't always go a full degree. So what are the pieces in between that? Well, that's where we actually separate them into minutes and seconds. So think of a degree as 1 full hour. And then the pieces of the hour, if you don't quite make a full hour or a full degree, then what we have are minutes that could separate the fractions in between. And then we have seconds as well for even the smaller fractional pieces. So this would be read as 56 degrees, 8 minutes, 10 seconds because of these symbols right here. Okay, so there's that. And then how do we convert these so that your calculator is just taking a degree amount? It's same thing if you, here's a small analogy, if you had 56 hours and 30 minutes and you only wanted that in hours, think of it like this, you would take 56 plus 30 out of 60, because you want to just get this in terms of hours, so convert this 30 minutes out of hours, and what we have are 60 minutes in the hour. So same thing with these. Oh, and so by the way, we would get 56.5, right? Because 30 divided by 60 is 0.5, and then when we add 56 plus 0.5, we get 56.5. So same thing down here. What we're going to have is 56 hours technically, or 56 degrees, and then plus you have 8 minutes out of a total of 60 minutes, because that's how these degrees are still broken down. They're very much like hours. So we're going to have 8 minutes out of the 60 plus 10 seconds, and total out of an hour we have 3,600 seconds. So when you simplify this, and I need a calculator, 8 divided by 60 plus 10 divided by 3,600, what we get is approximately, and I'm going to round to the nearest thousandths here, we have 56.136, and then that would be degrees. Okay, so that's how we do that conversion. And there you have it.